Hey there. Oh, I got some friendlies in the audience. This is great. So, I'm David Arbuckle. I'm going to talk to you guys today about uh, cloud portability, breaking cloud barriers, and things like that. Let's go. So, at MediaKind, I'm a VP of engineering. I'm responsible for our cloud and SaaS platforms and all of our video delivery infrastructure. And I kind of want to start this off by saying that cloud portability is kind of a lie. Like, we're all in the video industry. We've all had the experience of building an AV pipe or a collection of components and software to go deliver a connected experience to customers. But when we build that, what we're actually building here is an ecosystem. And if you imagine for a minute, if you were to try to move a rainforest, the Amazon, to a different place, one tree at a time, pick those trees up, move them. You might succeed in moving all of those trees, but at the end of it, all you're going to have is a bunch of dead trees and a bunch of confused animals. And that's because the forest itself is more than just the trees. It's the way that those things are connected. It's the way that everything integrates together in order to provide a service. So let's talk about MediaKind's MKIO ecosystem. So MKIO is MediaKind's platform for delivering a comprehensive video workflow, start to finish. And starting with processing, we do live and we do on demand. If you've got any video content, whether it's file-based or whether it's streaming, we can encode that and deliver it to clients all over the world. But for live in particular, the challenge is how do we encode, how do we stream with the highest quality, the lowest possible bit rate, and in a timeliness deadline so that we're not losing our audience because we've got too much latency. Customers expect a lot more from live. If live video is interrupted even for a minute, like imagine if at March Madness, the 1 minute of video outage is going to be national news. So the stakes are really high with live, and it's not the sort of thing that you can mess around with and just move around. It's a very difficult thing to get right. Once you've got live, if we're building applications, we really want to have the ability to monetize it. Like, we're all here to kind of make a dollar selling video and getting it in front of consumers. And what MediaKind and MKIO do is both server-guided and server-side ad insertion. So we connect our live encoders to ad decision servers. We provide inventory. And then when that inventory comes in, especially in live, we have creative miss and content replacement strategies that can go and fill that inventory as quickly as possible and encode it and deliver it alongside your live video content. And the faster we can perform that workflow, the higher the fill rate, the better the monetization, and I don't know about your customers being happier, but certainly our customers are happier when their fill rates are higher. But that's a big integration. There's a lot of moving pieces, and there's a lot that needs to be kind of put together in order to successfully deliver ads on live. On top of that, live content tends to be extremely valuable. The biggest brands in the world right now, the most iconic brands, are delivering live to audiences all over the world. And a pirate feed is a big issue, because the pirate feed is not going to include your ad inventory. The pirate feed is not going to earn subscription revenue. It's going to be a problem. And with MKIO's DRM, we've got the CIPX protocols and all of the technology that you need in order to protect your content and meet your sort of contractual obligations for delivery. So putting this all together, we start to see an end-to-end solution come together. This is the shape of the ecosystem. We've got live, we've got ads, we've got DRM. This is a very simple sort of example of it. And then we have delivery to clients and players. So with MediaKind and MKIO, we've got our player SDK, where developers can implement one time against a single interface and have a pretty strong guarantee that this entire workflow and all of the capability that it has with respect to just content playback, recovery, resiliency, multi-CDN, and ad delivery and DRM are all handled in a very simple and effective way. So as you're delivering content to clients all over the world, whether they're kind of in a rest of world environment or they're in a place with very fast internet, like our SDKs will make sure the content is playable on every device. And then on top of that, and it's not pictured here, we've got TV platforms that provide subscriber management, rights management, entitlement, and all of those other things. So this ecosystem comes together and it starts to grow and reach out. And we're kind of measuring a coastline here, right? Depending on where you look, you're going to see a ton of detail. But all of this end-to-end kind of comes together to create that environment of a video delivery platform. So that's kind of a whistle-stop tour, to use a British phrase, of MediaKind's software. And like when we're talking about cloud portability, we're not talking about moving live from one cloud to a cloud or DRM. We're talking about taking this entire infrastructure, this entire ecosystem and application, lifting and shifting to another place. And that's a much more challenging proposition than just running software, like one component in one place. So when I talk to customers, some of the things that I'm hearing in the industry are a little bit different than what I heard before. Previously, we would have a lot of conversations about best of breed and picking multiple encoders and having them all kind of in the same stack so that you can figure out and drive your vendors to give you better costs and more features. Honestly, a lot of video to me feels like it's complete. So, but what I am seeing is that customers really want to launch faster than they have before. There are demands to go get in front of your end users with a product that's differentiated and differentiates them from everybody else that's out there. You might have, like, the days when you could just go and ship a clone of Netflix are kind of over. Like, we need branding and brand identity. You need all of the content, and you need to have a really high quality of experience. What we're also seeing is that the choice about which cloud to use is something that's happening later in the decision-making cycle. Often you'll have sort of strategic partners with cloud. You'll have negotiation with the cloud vendor for preferred rates and things like that. And from an engineering point of view, like, we might have preferences. Like, it's great to pick and love a cloud. There's a lot of synergy that comes when you've got really great relationships with a cloud vendor. But when the business comes in and says, hey, we just signed a $100 million deal with AWS or with Azure, you kind of have to move your stuff there, or you've got to spend 6 months arguing. So, like, these sorts of things are these trends that we're seeing where cloud mobility is really important. The ability to move fast, especially with sports content, is really important, where you might have a limited window, a 3-month off season, to shift your workflows and workloads somewhere else. So let's get into some tech content. We kind of have 3 pillars of our portable ecosystem. Uniform infrastructure, automated operations, and a cloud control plane. And I'll go into detail about these in some future slides. But what these pillars are some foundational building blocks that enable us to pick up an entire end-to-end application and move it somewhere else with minimal retooling and minimal rework. So, Kubernetes and Terraform. We're really strong believers in creating a uniform infrastructure in every operating environment. Kubernetes is really great. I've been using it almost since the beginning, but it provides self-healing and service discovery. If your underlying infrastructure breaks or moves around, often workloads will move to other nodes in that infrastructure to recover. But it also provides an API for us to deliver applications that is agnostic to the environment that we're running in. You can deploy Kubernetes into AWS or Azure. You can have it running on-prem, on bare metal. You can be running it on OpenShift, using any vendor. At the end of the day, the API is the same. And our developers can also use Kubernetes and run it locally on their laptops. And what that means is that you can deliver and deploy and design an end-to-end, have a developer testing a completely integrated piece of code, piece of software, and then ship that out to customers the very same day. So our Kubernetes infrastructure across every cloud is created using Terraform. It's a terrific tool. We have a GitOps workflow for this, where all of our infrastructure is defined in Git, and we use continuous integration and delivery to run these Terraform scripts and stand up infrastructure. So it's very easy for us to expand to new environments. And when we're creating like new locations or regions, wherever they might be, this tool makes this repeatable and industrialized, which is terrific. On the operations side, we do invest a lot in automation here. So there's kind of three pillars to this. But Kubernetes operators, for the unfamiliar, are a piece of code that you run continuously inside of a cluster that, when a custom configuration comes in, can perform workflow related to it. And a great example of this would be performing a hitless upgrade or a hitless migration of a live encoder. If I've got a live encoder that's running and I want to upgrade the software version without interrupting my client experience, we use operators to automate that workflow so that we can stand up a peer, synchronize our encoders, and shift the workload and traffic over to the new one before tearing down the old one. This is really important, not just for software upgrades, but also for allowing us to manage infrastructure underneath the running application. So we try to create these interfaces. What's also great about these operators is that we can use them to extract over some of the cloud capabilities that we consume. Things like load balancers, things like DNS, all of the little ingredients that make up your cloud deployment. Well, if you have to integrate directly with the cloud, or if you do integrate directly with it, every additional place that you move introduces risk of a little bit of change. But these allow us to encapsulate that logic and to test it independently of the rest of our application. We also use these operators to perform continuous integration and deployments to our production environments. So we've got CI/CD pipelines that are doing daily rollouts of software to all of our locations as a progressive pipeline and a progressive rollout. And those deployments are monitored using the same production monitoring that we use for running workloads. So with this sort of stack in place, the change surface area is very small. The software that's going out can be tested at the most local level on a developer's laptop or a dev VM, all the way out to the largest production environments. And then when we do run into problems, and change always causes problems, not always, change always can cause a problem, but it's very easy to use this technology in the stack to roll things back and to undo what was done previously. Finally, with respect to cloud portability, we've invested quite a bit in our cloud control plane. So when you're moving a workload between clouds or between environments, the more that you have to integrate with the cloud specifically, and the more that you have to move over, the more that can go wrong. So our cloud control plane has a single API that provides a unified interface into every operating environment that our software runs in. So if you're running MKIOs in coding and DRM in East US, in Azure, and you want to move it somewhere else, you can spin up that other environment, you can do a parallel stack, you can test it, and you can migrate workload. But that control plane is never going to change. It's the same control plane across all of our environments. And that sort of API portability is really valuable because it provides you with the ability to effectively not have to change and retool your entire architecture when you perform a migration or need to be portable across other clouds. The control plane also provides a ability to understand a lot of the linkages between various different parts. So one of the things that I've experienced in the past is that you integrate a ton of vendors, maybe in a best of breed way, and there are 50 different dashboards and 50 different control panels that all need to be maintained in a wiki document somewhere, so you can go and find like exactly where it is that a problem may be coming from. Like the infrastructure gets very complex very quickly. With a unified cloud control plane and thinking about that end-to-end integrated experience, we do have the ability to basically represent all of the different connected components in one place. So when something does go wrong, when an engineer needs to do discovery and search and like figure out exactly what it is that might be causing a problem, having one API and one place to do it creates a really great hook for building automations and resolving complex issues very quickly. So, with that, I think I'll just wrap up. I hope this provides a little bit of insight into how MediaKind is managing our sort of cloud portability story. Like, we really do take an end-to-end approach. We're very interested in representing our software as a complete stack and having that entire stack be portable with very little integration burden being shifted to our customers and end users for how we for migrating across clouds. But this isn't an exhaustive list of techniques. This is just sort of a little bit of the foundational elements that have helped us along in our cloud portability journey, and I hope it helps you guys too. Thank you.